Dear viewers, in this video we will make an incredible journey through space with Voyager 1. This intrepid spacecraft has been soaring through the cosmos since 1977, and by September 2027 it will mark 50 years of its voyage. Traveling at a speed of 38,000 miles per hour, it's now 176 times farther from the sun than we are here on Earth. That's 24 hours away if you were traveling at the speed of light. Voyager 1's adventure began with a close-up look at Jupiter and Saturn, revealing Jupiter's massive storms and Saturn's stunning rings. It showed us that Io, one of Jupiter's moons, is bursting with volcanoes and hinted at a hidden ocean beneath Europa's icy shell. At Saturn, it found a thick orange haze on Titan, suggesting a world rich in organic compounds. Fast forward to 1990, and Voyager 1 embarked on a new mission to the stars. It's now beyond our solar system, in a place where the sun's influence ends and the vastness of interstellar space begins. Here it snapped the famous pale blue dot photo of Earth and continues to send back data that changes our understanding of the universe. Voyager 1, a spacecraft, talks to Earth using a big antenna that's about 3.7 meters wide. This antenna sends and receives radio signals across the huge distances of space. It talks specifically to the Deep Space Network, which is a group of big radio antennas in California, Spain, and Australia. These antennas are placed around the world so that as Earth spins, at least one of them can always see the spacecraft and keep talking to it. These big dishes can talk to spacecraft billions of miles away, like the Voyager space probes. The signals they send travel at the speed of light and can take about 20 hours to reach Earth. Voyager 1 is powered by radioisotope thermoelectric generators. These generators make electricity from the heat released by the decay of plutonium-238. This powers Voyager 1's instruments, computers, and radio transmitters. The generators lose about 4 watts of power every year, and by 2025, Voyager 1 won't have enough power to run any scientific instruments. After that, we won't get any new data or signals from Voyager 1, but it will keep traveling through space. Voyager 1 carries a golden record, which is a 12-inch disc made of gold-plated copper. It has sounds and pictures that show the variety of life and culture on Earth. It's like a time capsule for any aliens or future humans who might find it. The record has greetings in 55 languages, music from different cultures and times, sounds of nature, and pictures showing life and people. So how far can Voyager 1 go? Based on where it's going and how big space is, Voyager 1 is more likely to break down over time because of things like tiny meteor impacts, cosmic radiation, and temperature changes, than to be affected much by the gravity of a star or planet. It's possible that Voyager 1 could stay in one piece for hundreds of millions to a few billion years, unless it hits something big. By then, it will have traveled about a quintillion miles, which is only about 1.7% of the width of the Milky Way, but it would have passed by many stars. Voyager 1, a spacecraft, is currently moving towards a group of stars called the Constellation Ophiuchus. During its journey, it might pass by other constellations like Hercules, Lyra, Cygnus, Draco, and Camelopardalis. These constellations could have thousands or even tens of thousands of stars. Over billions of years, many things can change Voyager 1's path. These include gravity from things like clouds of molecules, stars that pass by, or even the Milky Way galaxy itself. As the Milky Way spins, its gravity, and the gravity of nearby galaxies and objects in space can slowly change Voyager 1's course. These changes might be small at first, but they can add up to big changes over a long time. Also, over such a long time, the stars will have moved a lot from where they are now. The constellations will change or even disappear as new stars are born and old ones die. This means that the galaxy of the far future will look very different from the one we see today. Because of all these uncertainties, trying to predict Voyager 1's exact path is more about guessing probabilities than knowing certainties. Things it might run into in space, like dust, gas, and other particles, will also affect its long-term path and condition. The spacecraft might also pass through areas of the galaxy with different amounts of stuff in them, from the relatively empty outer halo to potentially denser areas closer to the center of the galaxy. Each of these areas has its own unique gravity, but no matter what, Voyager 1's journey continues to show the spirit of exploration and discovery that defines human curiosity. As it travels through the unknown areas of scientific knowledge and understanding of the universe, it keeps teaching us new things. Thanks for watching.